So today's lecture will be about the triplet number 3 in waves. As I mentioned, this is a new approach, probably one of the first times a course like this, or one of the few times a course like this has been created to do science and art together, hard art and hard science, I should say. So we are in this third triplet where there's a Melodio chapter subtitled chapter 7 subtitled New Plan, and a Harmonio chapter subtitled chapter 8 subtitled Fughetta, and chapter 9 a Ritmo chapter subtitled Waves. And again, this is the third triplet as described: New Plan, Fughetta, and Waves, Melodio, Harmonio, Ritmo, respectively. So let's start with chapter 7, New Plan. And as per the structure of the book, it's in this Melodio chapters that go into the future as described here. So we're now moving a little bit further into the future. And in this, Tomas and the family are in Munich, and Max, of course, has the main offices of the hedge fund in Munich. And the story of the chapter is basically that Max has a deal with a Colombian drug lord, and that drug lord actually ends up going behind Max's back and essentially stealing his deal, stealing his money. And Max, this happened a while before, and Max is very upset about that. And he wants to use Thomas's idea, Thomas's device, to get his revenge on those Colombian, Latin American drug lords. So, but Thomas doesn't want to kill anybody. He's a doctor, and he doesn't want to do that. And so he comes up with a new plan that he's going to make the targets happy. And by being very happy, they are not able to fight off the other people in the team that will kill them. So this chapter explores things like happiness. Of course, it explores ethics and so forth, and a little bit of finance. And we'll look through some of these topics in this lecture. So in the beginning, it writes, with that twist of Seth's knife, Seth is the drug lord, Max's carefully crafted EJY crash ended up earning FARC is the Colombian group, some $100 million. A much easier job than trucking coke. Coke is the cocaine. After the dust settles, the body's cleared, the loss for Augustus Capital Management, which is the hedge fund, amounted to over $50 million. So not only did he not gain $100 million, but he lost $50 million. So with this unforeseeable, uncontrollable, unacceptable risk, for Max, there was one solution: to shut down the Dicker. And that was the nickname for Ceferino, Diago. So this is actually a very interesting concept. In finance, they have this concept of shorting stocks. And shorting stocks is essentially buying stocks and imagining or anticipating that they'll go down in price. So you get a stocks at the high price, and when they go down to a low price, you get a loan on those stocks, and based on the price of those stocks, and you can get a lot of money from that shorting strategy. This has actually been a concept that basically you profit from other people's loss. And in some cases in Korea, this becomes illegal. So to short stocks has sometimes been viewed as unethical, gaining profits from another person's loss. So this is interesting. Concept is that Max wanted to do this strategy, and someone else did this strategy, and ended up taking advantage of what Max wanted to take advantage. So is that really unethical? It's almost like one unethical and another unethical all combined. So we're not going to answer that question today. So they are on their way to Bogota at the airport in Paris. And Max fidgeted in his seat. I hate airports. Tomas, still peering at the squatting panoply of metal and flesh, smiled. I love airports. And Max curled his lip. What? Airports are my two favorite places are hospitals and airports. What are you smoking, homeboy? That's right. Airports, hospitals. Where else do you find so much diversity, so many comings and goings? Both are society's crossroads. Thomas waved his arm. So Thomas's favorite places are airports and hospitals. Uh, and of course, they're not really favorite places. Uh, on the, but on the other hand, they represent very critical times in people's lives. And so he describes people go to hospitals and airports for important, transformative things, not like picking up milk at the grocery. Max shook his head. And there's always the prospect of death. You never know if you'll survive the hospital, never know if your airplane will crash. But ultimately, it's about new beginnings, about hope and going or returning to a better place. So that's his two favorite places, uh, thinking philosophically about airports and hospitals. So this is a very important passage. I won't go through the whole one, but they're in the airplane, and Thomas is describing how he's thinking about Max and how he behaves. And he's thinking about being a doctor and what that entails. And he says a very important line here. In this regard, Thomas asked himself, what made a better doctor, knowledge or empathy? Empathy is a feeling. A troubling idea seeped into his consciousness. Was it possible yet Max could be a better doctor because he understood people as opposed to not just, learning medicine. Um, and then he reflected upon some comments. They were making some jokes, two comments. One irritated Max and the other one pleased him. The content was insignificant, the jokes, they were jokes, but its resonance with the listener, how the listener felt about it, is what mattered. And we have a phrase in Latin, operculum supra substantia. In other words, style or appearance over substance. We have a lot of that in politics. Most of you are familiar, of course, with America, with Donald Trump and all that. A lot of style, a lot of sort of talking and giving the impression, but not necessarily a lot of substance. And Thomas generally viewed truth in an absolute sense. All of you have science backgrounds, technical backgrounds, engineering backgrounds. So truth is absolute. Knowledge itself had value. The value of truth apparently was relative in terms of how people felt about it, at least in Max's world. So what is more important, feeling or content? Operculum supra substantia. What do you think? Um, Anybody want to comment on that?
I want to comment.
Sure. I didn't
Uh,
catch your name.
Yang Suyun.
Oh yeah, Yang Suyun.
Yeah.
Yes, great.
Uh,
So
I
you
don't
understand the
think.
concept, right?
Yeah.
Great.
I don't think we should be dichotomous about this topic, but if I should choose one thing, then I will choose the content. Uh, because if a doctor just have um, a, a doctor just have good feeling about patients, but he doesn't have content, then I think the patients can live.
Yes,
So I
right.
think, yeah.
I think that's a great answer because that is, in fact, the whole purpose of this course, if you will, or this part of the course of science and art. It doesn't make sense to view it dichotomously, just like you said, Miss Yang, in your opening comment. Of course, we can analytically separate them, feeling,
Mhm.
content, science, art. And in fact, like you said, if a doctor separates the feeling and uh, the content is very important. Like you said, the patient might not live, but there's many cases where the doctor was very rude, if it wasn't talking to the patient, they saved the patient, but the patient's not happy, and they feel like this was a terrible doctor. And we'll see more cases of that in the book. But you can't really separate them. If you separate them, not only does the patient not live, but they don't have a good experience. Being a doctor is more than just technically fixing something. And then if we think ahead, more broadly about this dichotomy between science and art, which is so intrinsic to society, it's intrinsic to uh, education. People do not doubt it. But if we think about it, why are they dichotomous? And so I think that's a great answer, Miss Yang. In a sense, the question is that they shouldn't be, separated. But as you point out, you would take the content uh, over. So in other words, substantia supra operculum. Thank you very much. Did I summarize okay? What you
Yes.
described? Yeah, very good. And you want to add to that, or anybody else? Okay, let's. Thank you very much, Ms. Yang. Let's go to the next one. This is a little bit of a side topic, but I think it's very important for the history of science. Uh, and I'll just read some of this. In those days, in those few days, they seem now so fleeting before leaving, before they left for the airplane. Thomas had feverishly worked on the serotonin receptor. Now, remember in chapter 6, the one called Happiness, where it's like a Gulliver's Travel. They're going all around the cell, and Thomas is teaching Nora, and he's describing it as a story. They talk about serotonin, about happiness. So he wants to manipulate the serotonin receptor. That's the serotonin is kind of the happiness molecule in the brain. We reviewed that in chapter 6. In order to create this happy state, that's one reason why chapter 6 developed this. He had even experimented on himself. I mean, everybody does this when they want to be happy with something. They drink soju, whatever, right? So this is not some sort of strange thing. But Thomas is viewing this scientifically. This reminded him of Cournand. Cournand was a very famous uh, doctor, actually at Columbia, where Thomas went to. According to med school lore, Cournand had one day tied down his assistant to prevent him from interfering with the experiment and forged ahead to thread a catheter into his own vein, actually through the leg. The tube still inside, he coolly walked over to the x ray suite and confirmed its successful placement within his heart. He had won a Nobel Prize for this research, or was it for his bravery? This feat had deeply impressed Thomas. He found it natural then to do the same with the happy ray, kicking Fritz out of the lab and testing it on himself. He was, to put it accurately, extremely blissful with the results. And then he experimented on this cat and all that, the story that you read. So this chapter also, not this chapter, but the next chapter, Harmonio chapter, will talk about courage. And the book Waves discusses courage as an immoral thing. But here I'm talking about science and courage. Can you imagine the bravery and the courage it took for Cournand to do that? Now, I'm not suggesting everyone, as scientists, should do these sorts of self experiments. But the implication in this book is that to do great science, to do the Nobel Prize, is not just about the research, but there must be some kind of bravery. This is an extreme form of that. That is the message of this passage. In other words, great science is not just the technical thing, but it is almost like a emotional, moral stance. Much like Miss Yang was mentioning about the doctor, yeah, the doctor can be great, fix the patient, but if they don't have that human element, in many cases, they're not going to get the Nobel Prize for for medicine. They won't get a great outcome. So that is the concept in this passage. So this is a very long passage. They're on the airplane. And I apologize. There's some, how should I say, four-letter words we say in English, but that is the way this Max talks. But the basic central point of this passage, Tomas says, my goal is to cure diseases. He realized the comment, true as it was, would not please his hedge fund manager. And basically, Max goes into a tirade and says, you are completely lost. Nobody cares about your diseases. Instead, pornography makes money, guns make money, drugs makes money. And that's what people want. They don't want to cure diseases. Of course, pharmaceuticals and diseases make money. But if you look at the big picture, it's these, other things, these negative things. And then he goes through curing diseases only eliminates the sadness. It doesn't make people happy. People want to be happy. So you can see that this happiness aspect is actually very important. You eliminate the sadness is not as powerful as, making people happy. People will pay for a dose of crack. Crack is cocaine before they pay the ER doc who saved their life. He leaned over and concluded his diatribe with a poke of his finger. Don't be stupid on me, Tomas. Alles klar? Alles klar is German for is all clear. So the negative over the positive. What do you think of Max's view of life? Anyone want to comment? Everyone talks about the positive things, but it's almost as if the negative makes the world turn around. What do you think? Anybody want to comment? I'll give you another example. Why is this passage important? Tomas is not, the incentive for this particular project, so to speak, that they're going to Colombia is to kill some people. That's what Max wants. And as you know, as scientists, as future scientists, there are a lot of military applications, and there are the medical side. And the military is very strong influence. If Moon Jae-in, President Moon Jae-in goes to you and says, you're a very smart student, I want you to work on new missiles to protect against North Korea. And you say, I want to cure some diseases, or I want to do something, positive. But he says, the fate of South Korea depends on your science. And so this is a very common dilemma. And I'm not saying you shouldn't do that, or you should, but the point is that deciding on what science you do, deciding on your projects, can have some of these elements of the societal bias or societal priorities. So now let's go to chapter 8, Harmonio, Fughetta. As you know, the Harmonio is in the first person. It goes into the past, time stretches, space compresses, and chapter 8 is down here, going into the past. And it basically describes Tomas during his beginning part, or actually the last part of his residency, and in neurosurgery. And he's with this girlfriend called Ava at the speed club, and he's describing some of the scenes, some of the situation. As I mentioned, courage becomes a very important part of this, because he eventually goes to a lecture by a professor whose life he saved, and that professor was talking about courage, and so Tomas reflects on that. So here's a YouTube link. Let's see if it works. It's from the beginning of that chapter. The night, a very strange night it had been, passed fitfully. The buffeting tempest had kept me up blinking, nailing me on sleeping to the bed. And as I watched Ava snoozing beside me, I asked myself how it had all gone so bad. Daybreak, miraculous like the high G in the Waldstein, filtered through the dimly glowing window. The morning promised a brilliantly bright, fresh November day. There, with veils of darkness bright, in the alembic's deepest member, glowing like a living ember, yes, like the finest garnet spark, shoots its flashes through the dark. So that's actually the Waldstein Beethoven sonata, and that high G is very miraculous because it's a very somber melody you heard in the beginning, and then that high G shifts it to this very clear and happy. And again, it's this concept of mixing two very different things, what Miss Yang had mentioned about dichotomous. So in this chapter, Thomas explores courage, which we talked about in the scientific sense with Cournand. And he writes, courage, what it is, greatly intrigues me. It seems so rare, cowardice, more common. So in other words, that's a kind of parallel to what Max was talking about, the negative over the positive. Cowardice seems more common than courage. You could say that life's miseries, its myriad dismays, its ever nagging angst, arises from the cowardice of others. L'enfer c'est les autres, hell is the others, once wrote Sartre. Along these lines, then, here would be my philosophic calculus. So he kind of makes a little sort of mathematical description of cowardice and uh, uh, courage mixing. So cowardice and cowardice together was hell. Cowardice alongside courage became purgatory. Cowardice beset by courage beset by cowardice descended into tragedy, and courage graced by courage rose to paradise. And on these points, eager for the professor's lecture, I looked to him for some enlightenment. And then he didn't really, say anything. And what's interesting is he that Dr. Williams had actually been in the emergency room, previous section, and Thomas was one of the people that had saved his life, and he was in coma and all that. That's what's described earlier in the chapter. And he says, "Hello, Dr. Williams. I enjoyed your lecture." I said, "Thanks," was the professor's response as he began stuffing his papers into his briefcase. I am Thomas Twarak," I blurted. And Williams looked up and said, "Who?" So it's kind of a little similar to this concept that Max was saying earlier. You can save someone's life and they don't really care about that as much as maybe, some other things. So at the end of this chapter, in the frame where they're talking with Dave, it was not my wish to be vague, but such things are complicated. Dave looked at his watch. Yes, we still had time, I thought. And so I asked, what do you think about courage or cowardice? For you, what you've seen, what's more common? Lips contorted, my friend cast me a peeved look, and then a smile washed over like he had arrived at some epiphany. Perhaps he had discovered the truth. And so was his answer. I don't know. Like you said, it all depends. So let's go to the last chapter in the triplet. It's chapter 9, the Ritmo. That's the dialogue. And the subtitle for this is Waves. And the subtitle, or I should say, the title of the chapter is Waves, and the subtitle is Electromagnetic Waves Have Personality. That's the key concept is in this chapter. So that's a little bit strange. Electromagnetic waves is science, and personality is humanism. But I will, in the next few minutes, describe this concept. It's not a scientific concept, but it's how many scientists view scientific phenomena through this kind of creative way. So here's chapter 9 of the Ritmo, which happens in one day, as we mentioned. So it's the third chapter in the Ritmo. So the student in this case, unlike Nora with chapter 6, is named Jason. And I don't know if you recognize, but Jason is not that smart a student. And of course, he describes a student. But it's interesting, this character Jason appears in several times in the book. Why is that? So you actually saw him, I don't know if you picked up on it, but in the end of chapter 2, that young man who's getting his book signed by Kostakis is actually Jason. Uh, and then later in the Melodio, one of the assistants, not just a junior assistant, like a aide to the president, is Jason. So here's the question: How did a very let me just stop something for a second. So then the question is, how can someone who's not very smart, uh, end up working with the president as an aide? I mean, he's a young person, so he's not senior, but still, how is that possible? And you'll see later, this concept of not always the best people end up in top positions or become successful. He also happens to be the son of a very wealthy person, so obviously money plays a role, and and so these are some of the aspects developed in the book. So Jason listlessly sauntered in, so you can see he's not very motivated. He pulled back the first chair he saw, which means he's not really 눈치가 없어요, 전혀 없어요. He doesn't really aware. He's a little bit oblivious to his surroundings. Jason, Tomas interrupted. That's my chair, the one in front of all the papers. The student stopped. He ran his hand through his jet black hair. So if you see the end of chapter 2, there's somebody with very black hair. And that's, of course, Jason. And looked down at the chair. Oh, okay, Tomas, he said. Thomas, he mispronounces his name. So he's not really very smart and as we say in Korean, nunchi 없어요. He said Thomas irked Thomas. Uh, so Thomas and Thomas. Several times he had corrected the scatterbrained student, but the error would never go away. Where should I sit? Thomas pointed to the only other place at the table. How about right there? They sat down to begin the session. The topic was waves. So one of the things with waves is there's a lot of, mathematics. So this is a part of the book Waves where there's probably the most mathematics, and it's not very complicated mathematics, obviously. But Jason is not very good at it, and so Thomas really tries to explain in a very simple way. And that's very important because all of you are science students, but this book is intended for a general population, so they may not have as much mathematics. And so I tried to make this as clear as possible. And that was part of the structure of this. So Jason says, Thomas, I'm getting tired, too much math. And Thomas says, stay with me. Galileo, did you know, once wrote, philosophy cannot be understood unless one first learns to comprehend the language and interpret the characters in which it is written. It is written in the language of mathematics. Jason says, but I still don't like it. So this is a famous quote from Galileo, and Jason is meant to represent many people who, have this math phobia. So Thomas keeps it simple. And I don't think this is the case with you because you're all very, obviously top students in science and mathematics. But why do you think mathematics education is dreaded by so many? Why is there a large group of people that hate mathematics? Any thoughts on that? Perhaps some of you hate it. Anybody want to comment? Mathematics education? Why do people hate math so much? Some people? Okay, well, one of my thoughts is that it's viewed very unartistically. So if you look at top mathematicians, and really great mathematicians, they start to view the mathematics in a very artistic fashion. Beautiful theories, elegant theories, and they really appreciate the beauty of it. That's not so easy to write in a textbook. It's not so easy to teach that, the beauty, of course, in early in school. But and of course, you have to learn the real mathematics, if you will, the content, like we talked earlier, and Miss Yang mentioned in the previous chapter. But if you don't have that artistic aspect to the mathematics, number one, you have a high chance of not enjoying it. And number two, you probably won't become very great at it. And so that's one thing that I want to mention. So when Tomas is talking about waves and their personality and almost the artistic aspect, uh, you may argue you don't need that to understand waves. You can just do trigonometric functions and whatnot. But in fact, it becomes a very powerful explanatory framework. So then Thomas talks about how waves are constructed and how they propagate on their own. So electromagnetic waves propagate on their own. Maxwell's equations, and this is the footnote for that, you don't need to know them, state that a changing electric field creates a changing magnetic field, and a changing magnetic field creates a changing electric field, and so on and so on. A moving charge, more specifically an accelerating charge, therefore, creates an electric field disturbance, the perturbation that then initiates a self-propagating electromagnetic wave. And so he draws the diagram, absent anything we feed on ourselves. This is B, the magnetic field changing. This is E, the electric field changing from the acceleration of charges, and a wave is produced. This is the basic concept in the self-propagation of electromagnetic waves. Now, I don't know if you have been reading the footnotes, but the footnotes develop some interesting corollaries to this. And so uh, in this footnote, the idea that accelerated charges radiate electromagnetic waves, energy, is central to physics, both classical and quantum. Uh, Feynman describes quantum electrodynamics, probably the core theory in physics. This fundamental theory of the interaction of light and matter describes the basic rules for all ordinary phenomena, except for gravitation and nuclear processes. So Feynman is right. Everything from the workings of radios to the bonding between atoms, even the blueness of the sky, arises from electrodynamic physics. It might be a surprise then that the concept of radiating accelerating charges actually comes with some controversy. And then I talk about how in quantum mechanics that there was some controversy if in the Bohr atom, Niels Bohr atom, if the electron is accelerating, it should be losing energy. But quantum mechanics resolved all this when it was realized that these electrons reside in a stationary state, unvarying with time. So they are not, in fact, accelerating. They're not particles. The question, moreover, being meaningless, as electrons in these states are not particles, but waves. But here's a very interesting next statement. Charges undergoing gravitational acceleration do not appear to radiate electromagnetic energy. So that's very strange. The efforts to resolve this conundrum are beyond the scope of this discussion, but such problems highlight how even the most rigorously held scientific convictions, in other words, this concept that accelerating charges create electromagnetic radiation, still offer openings for new insights, new paradigms. Who knows how this in the future will be resolved? So this is a very important concept, especially because the whole concept of the book is about proteins and their electrodynamic implications, which is against some of the established paradigms. So then Thomas is talking about the waves, and he's trying to make it simple for Jason, and he talks about the personality of waves. But here's the thing, is that this concept of waves as having a personality is not just a simplification. It's about how top physicists think about it. And so what he means by personality, good observation, you're exactly right. Let's move on. Now we can say that each type of radiation has a personality. What personality? What do you mean, Tomas? By personality, I mean a different way of interacting with matter. Energy interacts with matter. Electromagnetic waves are energy. Different wavelengths of electromagnetic EM waves interact with different parts of matter. This difference is what one might call the personality of the wave. So electromagnetic spectrum is all the same. It's just electromagnetic energy, and as developed in the chapter, with basically just different frequency and wavelength, which are inversely related to each other. Different frequency, wavelength, and energy, three parameters, and they're all basically governed by the frequency. So it's the same phenomena, but the same phenomena can have so many different effects. And that's what we call the personality. So X-rays are obviously very different than radio waves, but ultimately they're the same thing. And they have a different personality because the way they interact with matter is different, or they interact with different parts of matter. And so to summarize, each electromagnetic wave has a unique personality. Different waves interact with different parts of matter. It's like being attracted to somebody. Remember the Melissa story and so forth. When you first notice them, you may appreciate only some things about their physique, their personality. These may even lead to love, but other aspects are, at least at the outset, invisible. They say we never really enter love with our eyes fully open, and it's true. So this is what Tomas means about the personality of a wave. It interacts with different parts of matter. X-rays interact with the inner electrons of atoms, the highly bound states. Ultraviolet interacts with the outer electrons. Visible interacts with the outer electrons of very loosely bound atoms or electrons. Infrared is with bond vibrations. Microwave is with water rotation, among other things. Radio waves are with electrons that are very loosely bound in metals. So the final slide is Jason. Tomas proposes a mystery. As you can see, Jason got a little more interested in the course of the hour. I like mysteries. Tomas, me too. So here's the mystery. This region, this invisible region, is called the terahertz spectrum, ranging between 300 gigahertz and 3 terahertz, between the microwave and the infrared. Some questions for you. Why are we not aware of this frequency band? What parts of matter do these waves interact with? What, to put it in the same terms we've been discussing before, is the personality of these terahertz waves? Think about these and let's discuss next time. But for now, our time is up. So what part of matter does terahertz radiation interact with? The later chapters will describe how they interact with large-scale motions of these proteins. Not with the inner electrons of atoms like X-rays, not with the outer electrons of atoms and molecules like ultraviolet, not with electrons in metals like radio waves, but with large-scale, low-frequency vibrations of proteins. So next time, we're going to continue with the innovation course, either by recorded video. We'll do triplet number 4, which has chapters 10 of the Melodio, Brave New World. That's when they're actually in Colombia, in Bogota, and so that's a lot of action. Chapter 11, Eyes, which has a lot of neurosurgery in it. And chapter 12, Motion, which is essentially an overview of protein vibration. So you can see where that's leading, given the chapter we just approached or discussed. So any questions?